speaker is Jiska. Jiska is attending this conference since ages, like a decade, even more?
2022, C3.
So, long time. Sometimes she is also doing some talks here. The last one last year was about Bluetooth. There she was in depth. This time it will be a more general talk about wireless protocols, NFC, LTE, Wi-Fi, and of course Bluetooth. So she will tell us what is broken in all those protocols. So have fun and enjoy the talk. All wireless communication stacks are equally broken by Jiska.
So, welcome to my talk. I thought it first to be a foundation talk, but it will also have new topics about everything that is kind of fundamentally broken in wireless communication. And it will cover anything in your smartphone, so like NFC, Bluetooth, Wi-Fi, LTE. You could order them like by communication range or by specification length or lines of code. But the thing is, so the specification length and line of code also mean increased complexity. And if there is increased complexity, you might have issues with security in it in the very end. And then there is something that is even worse than LTE, which is vendor-specific additions. That would be when you open like 5 instances of IDA and like try to analyze where a wireless message is going and what it is doing. So most of this in this talk will be about wireless exploitation, and the new stuff will be fuzzing techniques and a new escalation target, but everything else is more like a general view on wireless exploitation. So first, to understand what the wireless exploit does is to separate it in different layers. So there's the lowest layer, which is some hardware chip which runs a firmware, let's say Bluetooth firmware, which is then attached to a driver. Then there's some privileged stuff. It depends a bit on what kind of system you're on. And in the end, there will be applications. And no matter where your exploit is, on that layer that you're exploiting, some security measures become ineffective. So for example, if there is encryption and you have an exploit for that layer, it would become ineffective. And it depends, so the higher you are, the higher also the exploit prices get. So for the Wi-Fi RCE, you would be at 100K. For baseband RCE with local privilege escalation, it gets already 200K. And if it's just a messenger or something, then it's like really, really high in the price. So the question is like, why is this wireless stuff a bit cheaper? Well, you need a certain distance. And so that's probably a thing. And then also, maybe they are just too easy to find. I don't know, like at least maybe for me, I don't know, for normal people. Or maybe the market demand is just not that high for them. Or they are not privileged enough. I don't know. But actually, they need like only like none or less interaction. So yeah, still a thing, I would say. So within the group I'm working at, we had a lot of wireless research and also tools that we released. And the first one, I think, that was running on a mobile phone is NFC Gate, which is currently managed by Max. Then there is Nexmon, which is our largest project, which is patching of Broadcom Wi-Fi. And Matthias, who did that, reached his goal by just saying, like, I now have kind of a software-defined radio in a commodity like Broadcom Wi-Fi chip. And so he was a bit bored and kicked off 2 new projects before he left, which he then handed over. The first one is Qualcomm LTE, and the second one was Broadcom Bluetooth, which I ended up with. And then we have someone else who is Milan, and he's doing stuff that comes more like from the application layer. So he implemented an open source solution for Apple AirDrop that you can run on your Raspberry Pi. And well, hackers gonna hack, so this stuff has been used a lot for exploitation, not by us, but by others. So there were 3 groups using Nexmon for Wi-Fi exploitation, at least like what is publicly known, and like the bigger ones. Maybe I forgot someone, but so there's a lot of exploitation going on there. Then Internal Blue has been used to demonstrate an attack against the key negotiation of Bluetooth just this August. And the Open AirDrop implementation was used for some honeypots at Black Hat and AirDOS, and like a lot of stuff is going on there. And then you might ask yourself, like, yeah, so if everybody's using it for exploitation, why don't we just do it ourselves? And we actually did that, and we even did that for this very first project, this NFC project. And the most important thing you need to know about NFC is that the near field is not really near field. So it's just communication, but it's not near field communication, which means, so if you are able to forward the communication, so for example, you have like your credit card and then a smartphone with NFC, you could forward it over the cloud or some server, and then to another smartphone, and then to the payment terminal. And usually there's no time constraint or distance bounding that would prevent this, so you can at least forward and relay messages, and you might even be able to modify them on the way. And some students of us did like some testing in some systems of some third parties, who then politely asked them to please stop the testing. So it was not really a cool thing overall, like not good to publish and so on. And the more happy I am about that there's other researchers who actually used some other tooling to look into NFC. So just this month there has been a talk at Black Hat, so not by us but by others, about the Visa credit cards, and it's just all broken. And it's cool that some people like just did it anyway. Yeah, so this is more about, so the NFC stuff is more about forwarding and the actual specification, but something that is also cool is if you get code execution within a chip, and this is a very different attack scenario, and for Bluetooth, I think it's especially bad because of how everything is designed. And the first design issue in Bluetooth is that the encryption key is stored in a way that the chip can always ask for an encryption key at the host, or it's even already on the chip, and there is no kind of security there. So whenever you have code execution on the chip, it means you can get all the encryption keys, not of just the active connection, and then break everything that is kind of a trusted connection by this key, and that even breaks features like the Android Smart Lock. And Android Smart Lock is the thing you can unlock your Android smartphone if you have a trusted device, and if you like add this, you might do this for your car, because it's nice in your car when you have like your audio and your navigation and everything without a locked smartphone. But the question is like, how secure is the Bluetooth of your car? Would you trust that one to unlock your smartphone? I don't know. And the next thing is, so if you have code execution on a Bluetooth chip, it also means that you might be able to escalate into some other components, so that you go up all the layers. Then next question is the exploit persistence. So let's say I have something that is running on the chip and, I don't know, extracting encryption keys or doing whatever. You might ask yourself, so how long will it be on the chip? I mean, it's just a Bluetooth chip, you switch Bluetooth off sometimes. And then the specification, so just at page like almost 1000, so that's like the first third of the specification. It says, note the HCI reset command will not necessarily perform a hardware reset. This is implementation defined. Then I looked into the Cypress and Broadcom chips, and so yeah, so if you do HCI reset, it's obviously not a full hardware reset, it's just flushing some queues, connection stuff here and there. So there is definitely memory areas where you could put your exploit and it would be persistent. So then you might say, yeah, okay, so what do? I don't know, I put my smartphone into flight mode for a hard reset. That usually doesn't work. You might also like reboot your phone. In most cases this works. For some other coexistence stuff, I had the impression that sometimes, so it's a bit strange, it might not necessarily like reset. Turning off for a while might hide reset the chip, I think. Or you just put your smartphone in a blender and then, yeah. So that might turn off the Bluetooth chip, finally. Yeah. So the next issue is, so let's say we have an exploit running there, but we first need an exploit. So the very first step is still missing as a building block. And after the talk last year, I did some stuff with Unicorn and fuzzing on the chip, and it was super slow. And then suddenly Jan showed up, and Jan said, hey, I want to build a fully emulated chip for super fast fuzzing and attach it to Linux, and everything should like run on a real, like as on a real system. Just the over-the-air input will be fast. And I was like, you cannot build this for your master thesis. And then he was building that thing within 3 months, and the remaining 3 months he was writing a thesis and emails to vendors. So here we go. What does Frankenstein do? So it's running on an evaluation board of that, it's just a normal Bluetooth board that's connected to a Linux host over UART and a modem over the air. And then you would snapshot that thing and emulate it and give it fast input attached to the real host. And that means that if you find some vulnerability, it might be within all the components, so it might also be on the Linux host, or it might be something that is full stack. So you have something that starts on the chip, gets to the host requests further things, and then it goes back to the chip. So you could build like quite complex stuff. And for this, I have a short demo video. So the reason why I do this as a video is that it might happen that it finds heap overflows otherwise, and then also it's not super stable at the moment. So you can see it's scanning for LE devices, and then Wireshark most of the time would get malformed packets, but sometimes it would also get normal packets and like some mesh stuff, whatever. So this is Frankenstein running. Yeah, so what Jan focused on is early connection states. That means stuff where you don't need a pairing, and then he found like heap overflows there in very basic packet types, so quite interesting. And then the stuff was fixed, I think, or hope, whatever, so at least like in very recent devices. And then the iPhone 11 came out, and in contrast to the specification over the air, the iPhone 11 says, hey, I'm Bluetooth 5.1. I was like, wow, first consumer device, Bluetooth 5.1. And I was like, I don't really mind my way of the exploitation as long as I can get code execution on the chip. So if it is with user interaction and a pairing and whatever, I don't care as long as I get code execution on it. And then I was like, okay, let's add some fuzz cases to Frankenstein, continue fuzzing, and then I found that specific evaluation board that Jan was building this for has a problem with the heap configuration for certain packet types. And so if you change that, you would hard brick the device. I meanwhile bricked 2 evaluation boards trying to fix stuff. So yeah, it's just bricked. And so that means for me to continue fuzzing to write, like to port something like 200 handwritten hooks to another evaluation board, it's almost running. So there's just some stuff with thread switching that is not super smooth yet, but like it's almost on the next board. And further plans are to add more hardware. So we are also working on the Samsung Galaxy S10 and probably a MacBook to get it in there. So then it would not just be Linux, but at least macOS, maybe Android, I don't know yet. And another thing that would be cool, and also we didn't build yet, but it might be feasible with some USRP X310 over PCI Express and with FPGA and all that fancy stuff to get real over-the-air input, which then would mean that you would have a full queue, like from over-the-air real Bluetooth packets going all the way up and then to a host and the way back. And you could also use that just to test your new modulation scheme or whatever you want to change, so not just security. So the next thing is, so if you have code execution, what do you do with it? And the normal approach is to try to go all the layers up, but there might also be some chip level escalation. And you might immediately see it on the next picture. So this is from a Broadcom chip, but that's something that you would also see in many other chips, which is that you have a shared antenna. And you could also have two antennas, but they are both on 2.4 gigahertz, and it's in the very same smartphone, super close next to each other, and you would get interference. So usually you just have the same antenna and do some coordination, like when it's Bluetooth sending, when it's Wi-Fi sending, so that they don't interfere. And this feature is called coexistence, and there's tons of coexistence interfaces, so this is just the one from Broadcom. And when I saw it, I was like, oh, Francesco, let's look into this. You know all the Wi-Fi stuff, I know all the Bluetooth stuff, let's do something. And he was like, nah, it's just a marketing feature so that they can like sell one chip for the price of two chips or something. And I was like, no, it must be an exploitation feature. And then to end this discussion, I went to Italy for eating some ice cream. And so reality is somewhere in between. It's more like it's hard-coded blacklisting for wireless channels and stuff. It's traffic classes for different types of traffic, for Bluetooth and Wi-Fi, and you can look it up in tons of patents, and it's like super proprietary. And so let's say we played a game, which was like I tried to steal his antenna, and he tried to steal my antenna. And so it turned out, if you do that, yeah, you can turn off Wi-Fi via Bluetooth, Bluetooth via Wi-Fi. And then, so like on most phones, you need to reboot them, and some of them even reboot them themselves. So this is just like a speed accelerated thing with a Samsung Galaxy S8 that is not up to date. For iPhones, you would just immediately see a reboot without any interaction of things going off and on. So Broadcom is still in the process of fixing it. I don't know if they can fix it, but they said they could fix it. But something you should definitely fix is like the driver itself, so that the smartphone reboots and so on. So I don't know. I thought it would be fixed actually in iOS 13 because it mentions Francesco and me, but still on 13.3, I don't know. It's still, you can still crash the iPhone that way. But it's just some resource blocking. So it's like not a super dangerous thing, I would say, and you still need Bluetooth RCE before you could do it and so on, but still not cool that it's still not fixed. So what about the other stacks and the escalations? So there's tons of different Bluetooth stacks, so it's really a mess. And obviously, because of Frankenstein, we had this first Linux Bluetooth stack attached and so on. But yeah, so what has been there for a while is 2017, these Blueborn attacks, you might have heard of them. And they found escalations like on Android, Windows, Linux, iOS, whatever. And then you might say, like in security, you often say, so someone looked into it, it must be secure now. And then there's so many features coming. So there's all these IoT devices. So everybody nowadays has wireless headphones and fitness trackers, and Bluetooth is always on. And in the Apple ecosystem, it's really a mess. So if you have more than one Apple device, you would have Bluetooth enabled all the time. Otherwise, you couldn't use a lot of features. And then there's like stuff like web Bluetooth, so Bluetooth LE support from within the browser. So it's like a lot of new attack surfaces that arise since then. So I think, so that's more like my personal estimation is like 2020 might be more Blueborn-like attacks. Yeah, so the saddest Bluetooth stack somehow is the Linux Bluetooth stack. So I don't want to blame the developers. I mean, it's not their fault, but it's like not enough people contributing to that project. And if you would try to analyze something that is going on in the stack, and you don't really know what is going on, you would do like git blame, whatever, and you would always see the same guy as the committer. So at least if you're like on a specific problem, then there's only one person committing there. And so the picture down there actually has like the same guy twice. So this is also a bit of a pun here intended. We did some fuzzing in there. We still need to evaluate some of the results. So yeah, but I also feel like nobody is really using it, and it's kind of sad. I mean, there's some Linux users, I guess, but yeah. Then there is the weirdest stack, I would say. So there's the Apple Bluetooth stack, and this one is actually 3. So there is a macOS Bluetooth stack, there is an iOS Bluetooth stack. They are definitely different. And then there's a third embedded one, for example, for the AirPods. They are all running different different things. So yeah, whatever. And then they also have tons of proprietary protocols on top of their Bluetooth stuff that are also very special. And I had like at least 2 students, just one porting into iOS, one to macOS, and then we also have students working on the other protocols that are on top of Bluetooth. And if you look into this, it's like, what the hell? So it's really hard to reverse engineer because you have like 3 different implementations. And then sometimes you're like, yeah, okay, maybe it's also just bad code. And in the end, so from what I saw so far, I would say that it's kind of both. Yeah. And then there is the stack that I played also a lot around with, which is the Android Bluetooth stack. And they did a lot for the security in the recent releases, and it annoys me so much that when I want to get internal Blue running on it, I just echo to the serial port instead, so I bypass everything that the operating system does. And so something that Android cannot do, which Apple does, is, so Apple has all the proprietary protocols, and if something goes wrong, they immediately cut the connection. But Android doesn't because of compatibility and stuff, so you could just send garbage for like 2 minutes and try and see what happens, and it would continue listening and asking and confirming. Yeah, but that's kind of an overall design issue, I think. And yeah, then there's Windows, and I couldn't find any students to work on Windows. So yeah, so if someone wants to do this, that would be great. Yeah, and so another stack, so that's kind of missing here is LTE, and I would call this like the long-term exploitation plans. So it's, I think it's like long-term evolution, whatever. But exploitation, I think, is the best thing for the E. Yeah, so we have like tons of wireless stuff where we are working on, and I mean like even PowerPC. And then there is Qualcomm, and they have this Qualcomm Hexagon DSP. I hate it so much. So there's even source code leaks for their LTE stuff, but it's just such a pain to work on it. So you might have noticed that Arash has this LTE project with Qualcomm, but it's just not fun. But other people were doing a lot in this area, and they've already presented here today and yesterday. So the first thing is the SIM card in the phone. So the SIM card should be a thing, like from my perspective, that should be secure because it protects your key material. And then it runs tons of applications, I don't know, and then you can exploit them and get the victim's location, dial premium numbers, and launch a browser. And then I didn't really understand, like, there's this WIB set browser, whatever, and then there's launch browser, what is it? And I think it even launches a browser then on the smartphone, whatever. It's just crazy. And then I was like trying to call Deutsche Telekom. And I'm a business customer, so it's like just like 3 minutes for a call for me. So giving a call there is nice. And then the first thing they told me is like, you are secure. We know you have 3 SIM cards and they are all up to date. So I have to say one of them is more than 10 years old, but maybe it's up to date. And my answers like, what exactly is running on my SIM card were of course not answered. So yeah, something is running there. If you want to know more about SIM cards, there has been a talk already yesterday evening, and it's already online. And then there's also a lot of people looking into LTE, and I think the most popular one is the work by Youngdae Kim. He did even some LTE fuzzing framework that he didn't release publicly so far because of the findings. So it's like, should you publish, should you not publish? But so the findings are super interesting, and he also had students here who just did a talk this morning. Yeah, responsible disclosure. So that's the thing, like when you find stuff, you need to do responsible disclosure. And so I said Jan was writing a lot of emails, and one of the first that he wrote was like to ThreadX, because ThreadX is the operating system that runs on the Bluetooth Broadcom Bluetooth chip. And so he said, like, your heap is a bit broken and does not have any checks. You could implement the following checks, which are pretty cheap, and it should be cool, and then I could not attack it anymore. And then ThreadX was answering, which was a bit unexpected, that they already knew about this exploitation technique, and that it is up to the application to not be vulnerable to memory corruption. So, or not to cause any memory corruption. So it's the programmer's fault if they do something and it's not the operating system that has to take care of the heap. Okay. Yeah, next issue. So the bin lifting and the testing, if a vulnerability is still there. So you might not always get feedback from all the vendors. If they fixed it, they may just fix it at a certain point in time. And then you tell them, oh, we tested the next release and it's still vulnerable. And then they would say, like, for example, Samsung said, yeah, we cannot send you patches in advance without an NDA because Broadcom, blah, 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 and so on and so forth. And then Broadcom offered to send us like patches in advance. And I said, yeah, nice. And I also sent them a device list because they already knew it from the previous process. So if we tell them the following 10 devices have an issue, then they would already know that we can test those devices anyway. And so, and after I sent them the list, they said, oh, wait, but you need an NDA. Okay, so no. I mean, we are doing this for free anyway, and then signing an NDA, I wouldn't do that. Yeah, so overall, also the Broadcom product security incident response team is a bit strange, so they wouldn't hand out any CVEs. And what I mean by I do is, like, I first get a CVE and then inform them and all their customers, because I also don't get any incident number or something. So if I wouldn't do this, I wouldn't have any number to refer a vulnerability to. And, well, at least they're also not doing that much legal trouble, but it's just, yeah, not really something happening there. But some of the customers were nice, at least to my students. So they paid, so one customer, they don't want to be named here, but they paid a flight to DEF CON for one of my students, and Samsung gave a bounty of $1,000. I mean, still, I mean, we are in the range of way more expensive exploits if it would be on the black market, but for students, it's definitely nice. Yeah, responsible disclosure timelines. So this is something that I thought, like, maybe some of this responsible disclosure timeline is just because of how I communicate with the vendor, and sometimes I'm writing emails like a 5-year-old or something, I don't know. But actually, so this is a timeline of Quarks Lab, who also found just this year vulnerabilities in Broadcom Wi-Fi chips. And so they were also asked about NDA, and then also their exploit timeline is a bit fun, because they had similar exploitation strategies as in the very first exploits that you could see by Google Project Zero. And then, yeah, more disclosure timeline, whatever. And in the end, well, it's just taking time, and again, no CVE ID issued, and so on and so forth. So it's the very same stuff for others, which is pretty sad. And then, so for Cypress, which is partially having source code of Broadcom and also manufacturer's chip, it's also very slow for the responsible disclosure. And then I got told by other people, like, yeah, if you would disclose something to Qualcomm, it also takes very long. And, well, luckily we didn't find something in an Intel CPU. But yeah, so on the wireless market, there's still so many other vendors to become friends with. So yeah, well. So practical solutions to end my talk. What could you do to defend yourself if you don't have a tinfoil hat? Other things I can recommend is the secure Wi-Fi setup. So don't use antennas, just use antenna cables. We do that in our lab a lot. So this is a setup by Felix. And so when I was sending my slides to Francesco in advance, he just said, like, cool, I have the same one right now at my desktop. So it's a very common setup. Maybe not at your home, but for us, it is. Or you just go to the AirGap device. So this is my PowerBook 170. That's a really great device, almost impossible to get it online, and it has Word and Excel. So ask all the questions.
Thank you very much, Jiska. We still have several minutes left. You will find 8 microphones in the room. Please line up in behind the microphones to ask a question. And the first question goes to the internet.
So, Herr Jiska, the question is, are the Bluetooth issues you were talking about also present in Bluetooth low energy IoT devices?
Yes. So, I mean, there is IoT devices. I cannot tell the vendor, but there's also some popular devices that have like Cypress Broadcom chips, and then it's even worse because they don't have a separate stack, but often they have an application running on the same ARM core, and then you don't even need any escalation.
All right, we have another question at the microphone number 1, please.
Thank you for the talk. My question is, did you actually, when you fuzzed the Bluetooth low energy chip, when you managed to get code execution, did you actually climb up the protocol? Did you access Bluetooth profiles or something like this?
So we, for example, for the thing with the link key extraction, we were building some proof of concepts. But so it depends. So we don't currently have a full exploit chain in terms of first on the chip and then on the host. We have something that goes directly on some host, but yeah, there's tons of things there to do. Sorry?
Yeah. And when you fuzzed how did you actually fuzz the chip itself? How did you extract the firmware from the chip?
So Broadcom and Cypress are very nice because they have a read RAM command, so you don't need any secure bypass or something. And for the evaluation kits, there is even symbols that we found in it. So symbols only means function names and global variable names, that's it, but that's something to work with.
Thank you. Another question from the internet, please.
Would you like the return of physical switches for the network controller?
Yeah, so that would be nice to physically switch it off. Actually, I don't know where Paul is, but he's building, here, there's Paul, he's building such a device. When is your talk? At 10 o'clock, Paul is giving a talk about a device where you have a physical control to switch off your wireless stuff.
Okay, the next question is again microphone number 1, please.
Yeah, thank you. We just bought a new car, and because connecting the Bluetooth of my phone to the car's system was very, very hard, and I had to reboot the radio several times, and then I found a message that the radio must be directly connected to the CAN bus of the car. So you have a Bluetooth stack connected directly to a CAN bus. It was a very cheap car, but if you have an idea what this means, then...
Can you borrow me that car?
It's a Toyota Aygo. You can have it everywhere. So.
Wow, that shouldn't be.
All right, we have a question at microphone number 8, please.
Hi, thank you for your talk, first of all. Well, if I understood correctly, you said that the vendors didn't mention if they fixed it or not, or you don't know if they fixed it?
Yeah, so it depends. So I know, so if you look into the Android security updates, so for example, August 5 has some Broadcom issue that was fixed, and I know which one that was, and so on and so forth. But so then it also means to get that one onto a Samsung device, I would need, so they wouldn't build it in the August update, but only in the September update, and then release it to Europe, which is mid or end of September, and then I could download it to my phone and test it over the air if it's really fixed and so on and so forth. So it's there is the first thing is that it's listed publicly that it is fixed, and then the next thing is that it is actually fixed and it's really hard. And for the communication with Apple, I don't know. So sometimes they fix it silently without mentioning us, and then there's this iOS 13 thing where they mentioned us but didn't fix it. So yeah.
Were there any issues that you found and you didn't know if they fixed it or not, and you did patch diffing or something like that?
Yeah, I did a lot of patch diffing, and I currently have a student who is doing nothing else than developing diffing tools for the particular issues that I have.
And did you find that they fixed it or not?
So it's first of all, it's currently about speed and stuff, and I gave him some iPhone stuff for the next task, but yeah, it's work in progress. So most of the other stuff I did by hand, so I also have a good idea about what changed within each kind of chip generation.
Okay, thank you very much.
All right, we had another question from the internet.
Yes, so from Mastodon, how exactly was the snapshot of the Samsung Bluetooth stack extracted for the fuzzing process?
The Samsung is, so for Samsung we have snapshotting, but for Samsung we don't have the rest of Frankenstein. The other stuff is running on an evaluation board. So the first part is mapping all the hardware registers. So this is the first script that runs and tries to find like all the memory regions. And once that is done, there is a snapshotting hook that you set to the function. So let's say you want to look into device scanning. So you would set a function into device scanning. And once that is called by the Linux stack, you would freeze the whole chip and disable like other interrupt stuff, whatever, that would kill it otherwise, and then copy everything that is in the registers. So that is kind of the snapshotting. And once you have a snapshot, then you can try to find everything that kills your emulation, like interrupts again and thread switches and so on.
All right, we have one more question from microphone number 1, please.
Okay, so do you think that open source, the driver, or that open hardware design would improve the situation?
So open source, I think it would improve the situation, but also one thing, so I had a talk at MRMCD in September this year. Another thing which is not about open source is that the patching capabilities of the Broadcom Bluetooth chips are very limited in terms of how much can be fixed. So just open sourcing wouldn't help Broadcom, for example.
Like you mean the firmware is burnt into the chip and it's limited to the patching is limited, right?
Yeah, so it's in the ROM, and then you have PatchRAM slots, and you have like 128 PatchRAM slot, and each PatchRAM slot is a 4-byte override breakpoint thingy that branches them somewhere else into RAM, and then RAM is also limited, so you couldn't like branch into large chunks of RAM all the time. Yeah.
Okay, thank you.
All right, if there are not any more questions,
Internet?
oh, more internet questions, then please go ahead.
Yes, so WinFreak on Twitter asks, what stack was tested when mentioning Android? There are several, and Google is convinced rewriting it every year is a good idea.
Yeah, so the stuff that's like the standard stack that runs on a Samsung phone, for example. So I think like for the main Android, there's only one. I know that there's like legacy stacks, but they switched to only one. Yeah.
So, Signal Angel, do you have more for us?
Yes. What is your hat made of?
My hat, so it's like aluminum foil, and then there is the cyber thingy. So that's also important. Yeah. So, but as I said, it doesn't really help. It would more help to put the smartphone in a blender, for example.
All right. Thank you very much for this awesome talk. Give a huge round of applause to Jiska.